Yes, we shall start with the second problem, the assignment. So previously we have done one problem on assignment. So this second problem is use the following cost matrix to determine optimum job assignment, cost of assignment. So we know all the different steps in assignment. So we shall relate those steps in this particular problem. So here in this problem they have given 5 machines and 5 jobs. So we shall solve step by step. So step number one is we need to check whether the given matrix is square matrix or not. Since the machines are 5 machines and jobs are 5 jobs, so it is a square matrix. So order of the matrix is 5 into 5. Okay. So step number one says. So step one is what? So step number one is it should be a square matrix. It should be a square matrix. So it is a square matrix. So step number one is satisfied. Okay. So we shall move on to the step number two. Step number two. What does step number two says? So in every rows you have to select the least element. Then that element you need to subtract from the all other elements in that particular row. That is step number 2. Okay. So we shall write step number 2 here. Okay. Here we have A, B, C, D, E as machines, J1, J2, J3, J4 and J5. Okay. So in row A, the least element is 2. You have to subtract this 2 from the entire row. So that is 10 minus 2 is 8. 3 minus 2 is 1, 3 minus 2 is 1, 2 minus 2 is 0, 8 minus 2 is 6. Okay, next the least element is 2, you have to subtract 2 from the entire row. So 9 minus 2 is 7, 7 minus 2 is 5, 8 minus 2 is 6, 2 minus 2 is 0, 7 minus 2 is 5. You have to repeat this for the entire rows. So 7 minus 2 is 2, 7 minus 2 is 5, 5 minus 2 is 3, 6 minus 2 is 4, 2 minus 2 is 0, 4 minus 2 is 2. In row D, it is 2, 3 minus 2 is 1, 5 minus 2 is 3, 8 minus 2 is 6, 2 minus 2 is 0, 4 minus 2 is 2. And in row E, the least element is 6, so 9 minus 6 is 3, 10 minus 6 is 4, 9 minus 6 is 3, 6 minus 6 is 0, 10 minus 6 is 4. So we have done this step number 2. Step number 2 says that, so in that particular row, you have to select the least element, then you need to subtract from the entire, in that particular row. Okay, so we shall move on to the next step. So that is step number 3. Step number 3 is what? Step number 3 is column minimum. So this is step number 2 is row minimum. So in this particular step, you have to repeat the same in case of column, right? So here again we have 5 jobs and 5 machines here. So it is 1, 2, 3, 4, and 5. 1, 2, 3, 4 and 5. You have different machines A, B, C, D and E. You have different jobs here J1, J2, J3, J4 and J5. You have to just refer this previous step. So you have to repeat this in the column wise. So in this column number 1, that is J1, the least element is 1. You have to subtract this 1 from this entire column. So again here 8 minus 1 is 7, 7 minus 1 is 6, 5 minus 1 is 4, 1 minus 1 is 0, 3 minus 1 is 2. Check out in J2 column, so it is 1, so that is 0, 5 minus 1 is 4, 3 minus 1 is 2, 3 minus 1 is 2, 4 minus 1 is 3. Again in J3 it is 1, so that is 0, 5, 3, 5 and 2. In J4 it is 0, right? So it remains as it is. Check out with J5 column, the least number is 2, so it is 6 minus 2 is 4, 3, 0, 0 and 2. Okay, this is step number 3. Okay, so next we shall move on to the next step, that is step number 4. So step number 4. So I'll just repeat the same matrix here. I'll write the same matrix here. Okay, 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Okay, I'll repeat the same matrix. 7 double 0 4 6 4 5 0 3 4 2 3 0 0 0 2 5 0 0 2 3 2 0 and 2. Okay, again here it is J1, J2, J3, J4 and J5. Here it is A, B, C, D and E. So yes, in step number 4, what we have to draw the lines that covers maximum number of zeros. We have to draw minimum number of lines that covers maximum number of zeros. That is step number 4. So okay, now we shall draw the different lines that covers maximum number of zeros. So here, if I strike off this J4, it covers maximum zeros. That is J4. Okay. Next, what we can do is we can strike off this. So it covers 2 zeros. So 1, 2, and again here also we have 2 different zeros. That is 3, and this line, because here we have 0. So here this step number 4 says we have to draw the number of lines that covers all zeros. That is step number 4. Okay, so moving on to the next step. Next step, you need to analyze whether the number of lines drawn is equal to order of the matrix. So here in this step number 4, we just need to check whether small n equals capital N. Small n is what? Small n is the order of matrix. Capital N is the number of lines which we have drawn. So here in this given problem, the order of matrix is 5 cross 5, and the number of lines we have drawn is what? 1, 2, 3 and 4. So means to say that the number of lines what we have drawn and this square matrix is not matching. Okay, so we need to repeat. So we need to go for the next step. What does the next step says? So if n is not equal to small n, so what does it says? So here the uncovered numbers we have read. Here we have these uncovered numbers, that is 6, 4, 5, 4, 2, 3, 2, 3, 2. So okay, so in these numbers we need to select the least number first. So which is the least number? Least number is here in this case is 2. Here in this case is 2. So we need to subtract this least number with all the uncovered numbers. That is next step. And one more thing you just need to remember here, at the intersection point, you mean to say at this particular point and this particular point, these are all the intersection points. That intersection points we need to add that least number to that particular intersection point. Okay, so I'll write step number 5 here. Yes, this was our previous step. So we have capital N. Capital N is not equal to small n, where capital N is number of lines we have drawn and small n is order of the matrix. Here capital N is 1, 2, 3, 4 and small n is 5 cross 5 matrix. Okay, in this case capital N is not equal to small n, so we need to proceed further steps. So what does step number 5 it says? So we have to check the uncovered numbers. In uncovered numbers we need to check which is the least number. So that particular number we need to subtract from all other uncovered elements. So at the intersection points we need to add that least number. Okay, so I'll just write it here. 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. So here you need to check the least number is how much? It is 2 in this case, right? Now subtract 2 from this uncovered elements. At this intersection points you need to add 2. Okay, so here it is 7, 0, 0. It is 2, 0 plus 2 and again 4 plus 2 is 6. Next is 4. 6 minus 2 is 4. 4 minus 2 is 2. It is 3, 0 and 3. Here it is 2, 0, 1, 0 and again 0. Okay, here it is 0, 2, 5. It is intersection points, so you need to add these numbers. Here in this case it is 0, 1, 0. Here it is 0 and 2. Okay, so after this step we need to draw the minimum number of lines that covers maximum zeros, right? So here we shall draw the minimum number of lines. So here you just need to check. So here we have 3 zeros, so I'll strike off this number. Again here also we have 3 zeros, I'll strike off this. So we have drawn 2 lines, right? So again at this A, right? So we have 2 more zeros here. Okay, that is again here we have 1 0, here we have 1 0, right? So if I strike off this, okay, and here 1 more 0. Okay, now you need to check whether capital N equals small n. Okay, here we have 1, 2, 3, 4 and 5. So means to say that so this condition satisfied, like n capital N which is equal to small n. So in this case capital N which is equal to small n is order of square matrix, capital N is number of lines drawn. If this condition satisfies, we need to move to the last step. So what is the last step? We need to proceed with the assignment part in step number 6. So you have to copy down the same matrix, then you have to assign, then you have to do the assignment part, correct? So I'll just write it once again here. 1, 2, 3, 4 and 5. Okay, so here it is 1, 2, 3, 4 and 5. We have different machines, that is A, B, C, D and E. Here you have different jobs, J1, J2, J3, J4 and J5. Just copy down the same matrix, that is 7, 0, 0, 2, 6, 4, 2, 3, 0, 3, 2, 0, 1, 0, 0, 0, 2, 5, 2, 2, 0, 1, 0, 0. So in the last step, we need to proceed for the assignment part, right? So here we shall do the assignment. So initially, what does last step says? So at row A, you mean to say that at machine A, you need to assign which is having a 0, right? So here how I can write? So in this row, I have 1 0 here, right? So I box this 0. I box this 0. Respective row and respective columns, if you have zeros, you need to strike off those zeros. So here you have 1 0, here you have 1 0, right? So I have assigned A to J2. Okay, check out with machine B. So here we have 1 0 here. You assign this particular 0 and strike off this 0. In row you don't have any zeros, in column you have zeros, so you strike off. In this column you have one more zeros, you strike off these zeros. Okay, next check out with row C. In this, here you have 1 0 here. Check out with this column, you don't have zeros. Here you have element. Anyways, you have cross, right? Like again in row D, check out with zeros. Here you have 1 0 in this row, and in this column, here in column you have 1 0. Go for the machine E. In this machine, you have 1 0 here. You assign this. Okay, this is step number 6. So here we have assigned, right? So for machine A we have assigned J2, for machine B we have assigned J4, for machine C we have assigned J5, for machine D we have assigned J1, for machine E we have assigned J3. Okay, so assignment is done for each machines. We have assigned one job, right? So in this problem they have asked optimum job assignment. Optimum job assignment, we have done the assignment part here. For each machines we have given each jobs. So next part of the problem is cost of the assignment. We need to find the cost of the assignment in this case. Okay, so how to find the cost? How to find the cost here? To find the cost of the assignment. Okay, so here we have jobs, here we have machines. Okay, so I'll write the jobs J1, J2, J3, J4 and J5. We have this for J1 it is machine D, right? For J2 it is machine E. For J3 it is machine E. For J4 it is machine B. For J5 it is machine C. Okay, so I'll write here cost. Okay, go to the original matrix. Here in case of J1 to D, we have J1 and we have D here. So in the original matrix it is 3, correct? So I'll write it as 3. J2 to A, J2 to A it is 3. Okay, we'll write it as 3. J3 to E, J3 to E, here it is 9. So I'll write it as 9. J4 to B, J4 to B it is 2. We'll write it as 2. Next J5 to C, J5 to C it is 4. So you add all this. So you have 3, 6 plus 9, 15, 15 plus 2, 17, 17 plus 4 it is 21. So this is the cost of the assignment. So that completes the problem.